Hello everyone, welcome to the machine learning course. Please get ready. We are about to officially start our class, and I hope you all can gain something.
Well guys, welcome back to our machine learning class. In this class, we'll move on to learn the examples on random forest algorithm. Firstly, let me show you the random forest performance. Now let's discuss the factors affecting the performance of the random forest algorithm. First, the performance
was influenced by the
single forest trees of the classification. The greater the classification of the strings of each individual trees in the forest is, the better the classification performance of the random forest is. Correlations between the tree in the forest also affect the performance. The higher the correlations between the tree is, the worse classification performance of the random forest is. Among all current algorithms, random forests have especially high accuracies among these algorithms. Besides, it can effectively operate on large datasets, and it can handle input samples with high-dimensional features without requiring dimensionality reductions or feature selection. And it can assess the importance of various features in classification problems. During its generation process, it can provide an unbiased estimate of internal generation errors. In the ensemble modules of Secunder, there is a random forest classifier class there. As shown in this code, we can find several parameters of random forest. N estimators indicates the numbers of trees in the random forest, which annual's default is 100. The max features is the numbers of features each individual decision tree is allowed to use. It can't take values like autos or long or script or numeric values. The criterion is to measure the qualities of beliefs, attributes. It can take values of gene or entropy. The max depth is the depth of the trees. The -1s indicate unlimited growth. The minimum sample split means the numbers of samples required to split a load, which default value is 2. The minimum the samples leave is the number of samples required to be at a lift load. Angles indicate the specified whether to enables the parallel computing. Let's have a quick analyze of this code. Let's start by importing arbitrary libraries. NumPy is used for numeral computations.
matplotlib
Pplot for plotting. Dataset for dataset handling, and random forest testers from secondary ensembles for creating a random forest classifier. Then, the code opens a file named KAN-text and reads its content line by line. For each line, it splits the line into parts and applies its first 2 parts to a list called X and the last part to a list called Y. After processing all lines in the file, the code converts X and Y lists into NumPy arrays. X becomes a 2D, two-dimensional arrays holding the features attributes, and Y becomes one-dimensional arrays holding the class labels. In similar terms, this code reads data from a file that seems to contain 2 features, values, and a class labels on each line. It then organizes this data into arrays so that it can be used for training a random forest classifier. The X areas hold the features values, and Y areas hold the corresponding class labels. This is an important step in operating the data from machine learning models. And then we train the random forest model. In the first line, it initializes a random forest classifier named CLF with a maximum tree depth of 5 and 10 trees. Then it fits the classifiers with the feature attribute X and corresponding labels Y. And then we create the classification boundaries plot. It defines the boundaries of the plot by calculating the minimum and maximum values of X and Y, and creates some mesh grids using NumPlay's mesh grid functions, covering the entire plot areas with step of 0.1. And then we make predictions. The classifier CLF is used to predict the class labels for all the points on the mesh grid. And then we plot the classification boundary. It fills the decision regions with colors based on the predicted class labels Z using the counter. For a smoother visualization, the original data points are then plotted using scatter with colors based on the actual class levels Y. And finally, the
Plot point show functions command displays the plot.
In most situations, we must tune the parameters when we train the model. The following 3 parameters are required carefully tuning as they significantly affect the predictive capabilities of the model. The first is the max features. Generally, increase the parameters can enhance the classification abilities of each tree, as there are more features available at each node. However, it also increases the correlations between any 2 trees in the forest, leading to a higher classification error rates. Additionally, increasing max features may slow down the accuracies. Hence, a balanced max features values should be chosen. Second, the N estimators determines the number of subtrees. The more subtrees improve the model's performance, but it can also slow down the program. It's advisable to choose a reasonably high values of the limits of computative resources to achieve better or more stable prediction results. Third, the minimum samples leaf. Leaves are the terminal nodes of a decision tree. Smaller leaves makes the model more susceptible to capturing noises in the training data. Generally, it's recommended to set the minimum
Leaf node count to a value greater than 50.
50s to prevent overfitting. Experimenting with different leaf size can help identify the optimal setting. In summary, tuning these parameters is crucial to balance the trade-offs
Between classification abilities.
correlations between trees, model speed, and overfitting. It's essential to find the right values to achieve the best and most reliable results. In this code, we use the dataset point make classification functions to split the data into training and testing set. And then we define the range of max features parameter. And we initialize an empty list, which is called K errors, to store error rates for different max features setting. And then we looping through the max features parameters for each values of max features. A random forest classifier is created with specified hyperparameters, including N estimators, minimums, samples leaf, maximum features, and N jobs. Cross-validation is performer. Use the cross-validation score, which divides the data into 9 folds and calculates accuracy scores for each cross-validation iteration. Error rates for each iterations are computed and appended to the k-error list, and then we plot in the graph.
A plot is created using Matplotlib,
with the x-axis representing different maximum features values, and y-axis is representing the corresponding error rate. Levels for the x and y-axis are added. And finally, plot show functions is used to display the graph. Here, I have a question for you. Is it possible to apply the same approach we used to determine the ideal max features values to figure out the best settings for unestimators and meaning samples leave as well? So, this all concludes today's course, and we will see you again in the next class.